to weigh in on why you've joined today's session, or what you're hoping to learn, or challenges you'd like to address. So this is your advance warning that we'll be calling on you for engagement. So to introduce today's speakers, our first speaker is Varun Padar, the Innovation and Entrepreneur Lecturer at Kellogg School of Management. Varun, if you'd like to say a couple of words about yourself.
Thanks, Liz. Hi, everyone. Welcome to the session. Excited to be here with you. I have about 20 years of experience in digital transformation, leading digital strategy, technology transformation, machine learning, and SaaS implementations across industries. At Kellogg, I teach a course on creating business value with AI. In that, we delve into AI applications in 3 key areas, including managing the customer experience, managing the operations ecosystem, and business support functions. We address over 20 industries, and that's what I'm looking to talk to you about today. Excited to be here. Thank you for having me.
Great, thank you, Varun. Next, Mark Thompson is the CEO of Amendo Energy in Australia. Mark, if you'd like to introduce yourself.
Thanks, Liz. Yeah, Mark Thompson. I've spent about 10 years in the Air Force as an operations and maintenance engineer. After that, I've spent about 10 years doing operations and maintenance of wind farms and solar farms, and also project development. So currently CEO of Amendo Energy, which we're looking at performance optimization and asset management as well.
Thank you, Mark. Over to Ramesh Rao, is a published author. So Ramesh, if you'd like to introduce yourself.
Sure. I'm excited to be here today, and good day to all. And I'm happy, and I thank you for being here today to listen to us and then to participate in today's discussion. I have been a sailor on the seas, sailing on the seas for 15 years, and thereafter I've been to the land and then worked with different organizations, including wind energy and then solar energy. So I see a progression like coming from the sea to the land, land to wind, and wind to the sun. And I'm excited to be here today, and I look forward to a fruitful session. Thank you.
Thanks, Ramesh. Finally, over to Lashman Rao. Lashman is the Principal Consultant for Bar One Cybertech, and he's going to be leading today's session. So Lashman, over to you to introduce yourself.
Yeah, thanks, Liz. My name is Lakshman, and I have close to 15 years experience in the renewable energy industry. And I've worked with many leading companies, researching, doing a lot of market research on the renewable industry space. I also have my business analytics certification, and I've been working in the analytics industry for the last 4 years after joining Bhawan. Very excited being here, a proper collaboration of analytics and renewable energy, and I understand that this will be a fruitful session along with our co-speakers here. Thank you.
Thanks very much, Lashman. So to get things started, as mentioned, we wanted to put a couple of questions to the audience. So if anyone wants to chime in here, just take yourself off mute. Hopefully a couple of people put their hands up. So we want to find out, what are you hoping to learn today? Or perhaps what challenges are you facing with regards to predictive analytics? Anyone feel free to chime in, or everyone feeling a bit shy today? No comments so far. Okay. Well, at any point, if people would like to chime in, please just feel free to ask a question. So without further ado, I will pass back to Lashman to introduce today's session and to begin the case studies.
Thank you. Thanks. Thank you so much. So first of all, thanks everyone for joining us today on this very interesting topic. Predictive analytics has been the buzzword in the wind industry. And it's been quite a lot of times that you would have come across this word. However, there could be a lot of questions for you regarding predictive analytics. We from BCT, we are leaders in this space of predictive analytics, especially for the renewable energy industry. And so we thought, like, we need to share our knowledge for the greater, industry requirements. So, we are conducting this session, and I hope, myself and my fellow speakers would help you to get answers to a lot of your questions on the predictive analytics space, and break some myths, unravel some realities, and also, it'll be helpful for you for sure, where you would be going with a lot more inputs about predictive analytics. So before we go into the presentation, we just like to talk about what Bhavan Cybertech is all about. So Bhavan Cybertech, or BCT, is a digital transformation company. They generally provide services on digital transformation. BCT has delivered solutions globally in across 20 countries with its products and services. BCT has been operating for over last 2 decades. And in the US, we have offices in Boston, Santa Clara, Atlanta, Houston, and New Jersey. We focus on 3 areas mainly: predictive analytics, digital experience, and digital supply chain management. BCT is one of the most trusted digitization partner for many Fortune 500 companies across the globe. BCT's success stories has been featured in case studies in management schools of Stanford and Kellogg for cohorts to learn. So going through the agenda for today, in this workshop, we will be covering topics related to predictive analytics for wind power generation. The agenda will basically start from understanding the wind turbines that are coming these days, how it is getting complicated on a day by day, and what are the frequent impacts, frequent downtimes, or the faults that are coming up in this in the recent wind turbines. We will also address some key questions that come in your mind regarding predictive analytics. Per se, like, does predictive analytics really help? If it is able to predict, at what stage it is able to predict? Whether it is able to predict when the faults are reversible, or it is when you have to really go and replace the equipment altogether. Are there robust predictive analytics solutions that are available in the market? Or, these are some of the questions that we will be talking about today. And in the end, I will also talk about what would be the realistic business benefits that a predictive analytics solution can provide. Now, before we go into the topic of predictive analytics, let us see how complex wind turbines are getting day by day. If you see what turbine you have seen in the past 2 years or before 2 years, maybe somewhere around a 2 megawatt or a 2.5 megawatt, whereas currently the turbines have gone up to even a 3.5 or a 4.5 megawatt turbine as far as our onshore is concerned. So turbine capacities are increasing, turbine rotors are getting bigger, the blades are getting bigger. The blades are even lighter, but they also look for sturdier blades. So the reliability standpoint is also coming to the play. To manage the higher sweep areas of blades and rotors, there is a need for a performance optimizing control system that is also coming up. There are improvements that are happening in pitch systems, yaw systems. The gears and the generators are coming up with ultrasonic vibration sensors per se. So these are not the turbines what we have seen in the past. However, if there is a breakdown that happens in a turbine, it is going to, your big amount of capacity is going to get stuck, because where you've lost 1 megawatt, say 3-4 years back, for the same one turbine, you're going to lose at least 3.5 or 4 megawatt per se. So this is where predictive analytics becomes very important in these days. Now, we will also see what are the sub-components that are there or sub-assemblies that are there. To achieve, there are many sub-assemblies per se as far as a wind turbine is concerned. To achieve an optimized energy production or higher availability, all these components that are there in the sub-assemblies should work in tandem. So as you could see in the bottom section, there are components that we have listed. And these are the components which are having a likely possibility of getting faulty as and when, or likely possibility of having an anomaly. So my first question for today's workshop is goes to Ramesh. Ramesh, I just wanted to ask you one thing. With your experience, can you please explain which are the most critical and the frequent parts that go for downtimes?
Thank you, Lakshman. While there are several failures that happen in a wind farm, and they all result in energy loss, but I shall pick up only the significant ones that I have come across in the recent past. And before we proceed to explain the failures, let me say that the downtime can be due to failures that occur because of a wear mechanism, or it could be because of fatigue, or it could be because of lightning impact. These are the three major impacts which cause longer downtimes. And when we come to the wear-related issues, then we have the main bearing, the gearbox bearing, the gear teeth, the pitch bearing gear, and the yaw, and the hydraulic actuators. And then the fatigue-related ones are the ones which I'm able to see now more often in wind farms, both in the US as well as in India as well. And these are mainly to do with the pitch bearings, the blades, and the gearboxes. Now, since you just mentioned that the blade lengths are increasing, and then we have higher tip speeds because of the larger diameters, the larger the length of the blades, the force on the bearings, the load on the bearings is I would say 3x or up to the fifth cube. There is a load that comes depending on how the wind speed changes. So these loads, for whatever reasons, they have not been assessed to an extent that we could put in safety features. So I have seen recently there are more failures in pitch bearings and the blades as well.
Thanks, Ramesh.
See, another thing which I want to add here is that most of our activities on the wind farm today is geared toward detection of wear-related issues. And these failures are actually progressive in nature. There is at different stage of failure, they have different indicators which could be picked up by sensors or by any kind of a special how we define failure is what is going to decide how we are going to maintain our machines.
Sure. Thanks, Ramesh. That was very helpful. So we have actually, from a global study, we are able to see how failures have been distributed in a wind turbine machine. So there are two box plots that are given here. The first box plot actually talks about the number of failures per turbine per year. And the other box plot talks about the downtimes in number of hours for every failure or every related failure. So we can see that the most frequent downtimes are basically the pitch and the electrical downtimes. So what you see in the first box, and you can see that there are also rare downtimes per se of that of blade or main bearings or gearbox or generators. But if these kind of downtimes happen, there is a higher impact of production loss and as well the cost, because the time to put back these machines into service is much, much longer. So it is essential that if you're going for a predictive analytics solution, that both these things have to be taken into consideration and ensure that the solution gives you, the predictive analytics gives you solution for both these problems. So with this, I would like to launch a poll, which you audience can please answer.
Great. So we're just, the poll's just launched. You guys should have got a pop-up. So we'll just give it another sort of 15 seconds to get the results in. Great. Okay. Well, I'll end that poll and hopefully see the results. So can you just confirm that you can see this? Yeah. Cool.
Great. Thank you. So I think we are actually found that people are having problems with the larger equipment. So almost 48% of people have answered that they have problems with gearboxes and generators or any kind of large equipment. I think this is why I think the topic that we have taken makes a lot of relevance for this kind of feedback that has come in. Nevertheless, we will also be touching upon the other areas that comes here. But we will be focusing mainly on the predictive analytics part, in this presentation, which is substantiated with these polls. Thank you so much.
One thing, Lakshman, I can chime in there was what's fascinating that you see there is with machine learning, as you build your models, you really need to think about the problem and the objective function, because with each lens, then can you go at the solution. You cannot take a model that's designed to detect large equipment failure and start to put in, have an expectation of optimizing efficiency around it. So this step of trying to identify which problem you're going after and then honing in on the solution, the variables and other details that you were going to talk through now, it becomes really important to hone in that upfront business problem that you're trying to solve.
Absolutely, Varun. Absolutely. And Mark, I would also like to share, your views on this findings, Mark.
Sorry, I did the old mute, unmute trick. Yeah, look, we're at a stage of our assets that we're more focused on efficiency because we've gone through the process and we're using predictive analytics, and we're not so focused now on, the big downtimes because we can avoid most of them. So, we've got spares in place, we've got all our processes happening. So we're really focusing on efficiency there for the assets that I own. I know that a lot of other owners in Australia are just starting the journey on predictive analytics. So, yeah, they're more focused on the big ticket items. I think pitch bearings is probably one of the biggest ones we have, but obviously the big ones, gearboxes and generators. And we're seeing more direct drive machines in Australia too, actually, come into the market. So not so much the gearboxes on those.
Excellent, excellent. Thanks, Mark, for that. So now, as we have spoken about the downtime, and people have also responded that bigger equipments are their problems. I would just like to talk a little about planned downtime versus unplanned downtime. So, what is the kind of impact that you will be having against a planned downtime if you per se have a sudden breakdown? So now some facts about this. If you see the O&M cost on an LCOE scale is around $14 per megawatt hour, considering that it's 28% of LCOE. The cost impact of an unplanned downtime is at least 3 times compared to the cost of a planned outage. So if an unplanned downtime is not converted to a planned downtime, the end result will be, end of the day, lower yield, high maintenance cost, and high rate of asset degradation. Mark, I would also like to, ask you another question. What are your thoughts on converting the unplanned downtime to a planned outage? What are the best practices that you think we need to follow?
It's a good question. So I guess in our experience, early detection, you know, and using the data that you've got is key to this. And predictive analytics is something that's really helped us. We started a couple of years ago and on one of our wind farms, and you know, when we started using the analytical tool, immediately picked up issues such as, you know, pitch bearings, nacelle not facing into the wind, and these were really easy things to identify, really easy things to fix. And you know, we picked up better availability. Technicians were also more on the ball in terms of fixing things and identifying things. Now we're at the point where just, I think it was 2 weeks ago, we had a spike on the temperature of one of our transformers on one of our turbines. Technicians went out and changed 2 faulty fans. Now, if we hadn't picked that up early enough, we would have lost the transformer and it would have cost us probably $200,000. Didn't actually have a transformer spare in stock, so it would have been 3 to 4 weeks of downtime. So averted a major event and costs just through, you know, a really early detection. So it's things like that. You know, we just need to be on top of our data and use that to the best possible way.
Thanks, Mark. That gave a clear-cut case in point as well, with a lot of benefits that you explained. I think that was an excellent point. So, okay, now that we have come down to that predictive analytics is important, first let's understand what predictive analytics is all about. So a key prerequisite as far as predictive analytics is concerned is getting the right data and also the accurate data. The sources of predictive analytics can be a SCADA, it can be a vibration monitoring system, it can be weather station data, it can be downtime data. So all this, the parameters, the kind of data that comes in would add in a lot more value to the kind of, you know, the predictive analytics that we are going to do. And end of the day, this will ensure that we have higher accuracy. Now, once we get the data, there are 3 steps that we follow. So the first step basically is where we pre-process the data, we clean the data, remove all the outliers, you know, in the data. We impute some missing values wherever we find that there are values that are missing. Sometimes if there are too many observations that are missing, maybe we have to segregate it, you know, separately. And then we find out the predictor variables for a specific problem. Per se, if you're doing a model for a gear bearing temperature, we have to see what are all the predictor variables that will predict your gear bearing temperature. These are basically the sensitivity analysis that we need to do. And the second step is where we take this data, we do models on this data, and depending on the kind of the data, depending on the kind of the problem at hand, we select the models. And once we select the models, we run the data in these models and we give outputs. So the outputs are mainly due with respect to the deviations that come out. So with these deviations, as we go to the step 3, where depending on the rate of deviation, how fast it is increasing, depending on all these areas, we give forewarning and alerts well in advance. So just to give you a quick view of how a sensitivity analysis is basically done. So here, if you see, we are, as an example, we have taken a gear bearing temperature, and you can see that in the right end, there are probability values. And wherever there are 3 stars marked, these are the values that are significant, you know, for a gear bearing to perform properly. So we are actually doing all the sensitivity analysis here, and it is required that all this data should be necessary to predict a gear bearing temperature. So if there is, so this is the way that we generally do a sensitivity analysis part and come out with the right set of parameters. So Ramesh, with my interaction with various customers, they say that they are not getting much of data, and it has always been a challenge for them. So do you think that with the existing data that they have, the predictive analytics is possible?
Yes, Lakshman. I wouldn't say data is an issue, but rather it is the information that is the problem. Okay, getting information from the available data has been a challenge all the time. And see, our customers are right in saying that there are some issues with only certain OEMs, but not all of them. And there are certain OEMs, few of them, who gave only limited data to the IPPs, the owners. But then they have, for their own analysis, they have the complete SCADA data, the condition monitoring data, and then they also have something known as the digital twin, based on which they are able to prepare predictive models and then help the customer, or I would say rather they are expected to help the customer with advanced warning system, but it usually doesn't happen. Okay, now coming back to the data part, the data, I would say that I wouldn't say it is less, but it is enough to carry out sufficient level of analytics so that we are able to get the information that matters most to us.
Excellent. Thanks for that. Varun, I would like to understand from you, are there any areas with respect to new models that are coming up where these models can help us increase our accuracy of the output? Are there any data science new evolutions that are happening?
Constantly, I think the key there'll be new models for like deep learning models, different kind of neural networks. You might do some things that you're doing manually today. Now you might do, for example, a drone-based visual inspection. Then you suddenly need new models and new data sets to kind of put that to work. What's critical as these new models come about, more than the model itself, is the data wrangling piece. Data wrangling is truly 80% of the work on an ML project. And that's what I think, Lakshman, you're showing here is the effort that goes into pre-processing, instrumentation, sort of picking the right variables, looking at the correlations and saying which of these variables are truly going to drive the predictability and the power of that. And one key concept why that comes in and becomes so important, no matter what level in the organization you're at, is what we teach in the course called responsible AI. And that's at the heart of this. We define responsible AI as initiatives or AI basically that's designed, governed, and implemented to mitigate the adverse impacts and to kind of maximize the positive outcomes. Now, why is that important? Because that ultimately creates trust. And one, I won't go into all the 6 principles here, but one key principle that this ties to directly is explainability. Now, as an operator, as an executive, as the decision maker, you need to be able to understand these variables and to explain whether they're this, deep learning based, whatever your models are, you need to be able to explain them and be accountable for the decisions of those systems. When some system comes up and says, shut down today, you need to be able to explain it as to why is that saying so. I mean, should you truly shut down and risk revenue? Or do you take a backseat and say, nothing's going to happen, I don't trust the model? And that is where this lies at the heart of that. You're able to understand, interpret, and articulate why the model arrived at that decision.
Great. Yeah, I think that's very important, Varun. Thanks a lot for that input. So I'm just showing you an example of how we are doing an error plot. If you see that we have plotted an error histogram for gear bearing temperature, you can see that in the month of February, there's a sudden increase in the errors and it's been quite persistent for some time. And then after the interventions have happened, you can also see that there is normal levels of errors that are coming in. So this is just an example for gear bearing, whereas this can be replicated for generator bearing, main bearing, transformer, pit systems, or any of such issues that keep coming in the plant. So this is just an example for you to understand how predictive analytics basically works. So we are also, we have to now convey this in the right way so that users are getting, the right set of inputs in a way they can understand. So we are actually giving an advanced warning. And in fact, the warning is well before, the SCADA alarms that can come in. And this is very important that the visual intelligence of this has to come in the right areas, so that people are able to understand the outputs in a correct way, so that they don't perceive anything wrong from these kind of the visual intelligence that we're given. Mark, can you please add up how you can emphasize the importance of visual intelligence in your experience, Mark?
It's massively important. When you think about the amount of data that's coming in, some of these new turbines have, hundreds, thousands of data points, and trying to wade your way through these and work out what's going on. It's near impossible. I remember when I was at Vestas, they used to spend days, doing pivot tables and spreadsheets, and just trying to find the right way to present it and work out what's going on. So presentation is everything. It makes it really easy to see what's going on, identify issues, areas to kind of deep dive and look into in more detail. So without a really good user interface, visual sort of presentation, it helps immensely. I can't stress it enough. It saves time, and by saving time, you save money. That's what we're all about.
Great, thanks, Mark. So it's not necessary that your analytics have to be always predictive. There are some times that, as Mark was rightly mentioning, there are some insights that you can get without having predictive analytics. So this is one such case where we have actually identified generator misalignment by increasing temperatures of generator drive end and non-drive end. So this is through a concept of health index, where for a couple of days we found this problem, and as soon as we saw that for a couple of days, the field guys were actually instructed to go and check this, and then they had found out that there was a problem with the generator. It was misaligned. They had again done the realignment, they done the greasing, and then the temperatures came back to normal. So this is one such example where you can also find the problems in the root cause, so that you don't have higher energy losses or any kind of catastrophic failures that may happen. So now I would like to pause here and take an audience poll just to understand how is their O&M practices happen.
Great, thanks. So we'll just launch the poll again. So if everyone can get their answers in, we'll try and, I guess, keep it to sort of a minute for answering, but I can see they're coming in quickly. Cool. So just a couple more seconds if you've not got your answers in yet, but thanks again for voting, everyone.
That's, I think the results were as expected. This is where 52% of the crowd is saying that they have gone for a long-term service agreement with the OEM. So I understand that this should be along with the parts support as well. So thank you so much for the responses. Ramesh, at times IPPs wonder why they need a predictive analytics tool when they have a long-term service agreement with the OEMs. Can you just give an understanding of what makes it more necessary to have a predictive analytics tool in that case?
Let me answer it this way. Now let us look at what kind of maintenance philosophy is followed. Either you could have a failure management or a performance management. And then all along it has been mostly failure management, but of late there has been a shift towards preventive maintenance. So my question again is, what are you trying to prevent? Are you preventing a catastrophic failure, a functional failure, an unplanned downtime, or is it a performance loss or an energy loss, or is it a loss in reliability, or is it creation of root cause conditions? What are you trying to prevent? And as I had mentioned before, we have progressive failures, and there are enough indications all along the degrade curve to detect a point where a component has started degrading. So either we choose to detect it early or we detect late. Now, the third point is, I come across this question most of the time as to why we need to go with predictive analytics when we already have a SLA. But I think in this case, this is not exactly a good question to ask, mainly because the contracts and the SLAs are heavily loaded in favor of the OEMs. They're one-sided contracts. And I say that because there are too many limits and exclusions and sunset clauses in nearly every clause that is there in the agreement. I have yet to see an agreement where there is a protection against subtle failures. There is a protection against the obvious ones, like a gearbox failure or a blade failure, but the subtle ones, I would call the subtle ones as the ones like a degrade, a start of a degrade of a pitch bearing, or aerodynamic loss in a blade surface, or it could be the main bearing where the wear has increased. It is much beyond, and it's not consistent with the operating hours. These are the failures which are not usually detected, and it is not there in the contract. So I would say that even today, what is being done is only failure management. It is not performance management. And then another aspect of this entire thing about contracts and wind farm operations is the LCOE factor, which you had brought up some time back. And then the significant aspect of the LCOE is that CAPEX happens to be the one which is with more sensitivity. LCOE is more sensitive to the CAPEX, but it is also sensitive to finance. The finance, so correct. The finance and the CAPEX are the fixed part. Okay, finance cost. But then the O&M cost, the capacity factor, and then the extended lifetime. These are the ones which impact the LCOE to a very large extent. And then if you are able to manage performance of the turbines and then arrest the wear at the early stage, then it is obvious that the operating life or the economic life of a project increases much beyond the initial design stage. So that's when the profit starts rolling in. And extension of useful life, optimization, energy loss mitigation, or performance improvement is not a part of any contract. Whether it is a comprehensive contract or just a service contract, it is not. So I feel this argument actually doesn't, there shouldn't be any argument at all, unless they're able to get the OEM to work on the performance part. And then here actually there's nothing much that the owners can do other than having a very strong contract and SLAs with them. That is what is needed here. And
sure.
Not to mention the data part as well, because a part of the SLA is also having the data and the information to act upon.
Absolutely, absolutely. Thanks, Ramesh. So, so this is what the data part challenge is what we want to talk about next. So, if you see, there are quite a few. There are sometimes challenges that the OEMs don't share the data. So what should basically an IPP do for this? They have to start leveraging some of the key negotiation skills, rather I could say, that when they negotiate SLAs, they have to add the right clauses. And they have to ensure that these SLAs have these clauses with respect to data sharing, or with respect to any kind of actions that they say, any kind of suggestions that they say, the OEM should be open to accept it. And similarly, it is also, on the other hand, very important that they have to share the right inputs to the OEMs. And they should not have many false positives, because we have to be very wary about that OEMs also have their own work, and they can't keep going around with their false positives. So with this, I would also would like to go to the next slide, which talks about the critical success factors of deploying predictive analytics. Now, there are quite a few success factors. The first and the foremost being that there has to be a clear objective. As Ramesh rightly stated, that we have to know for why we need to, what is the end objective of having this predictive analytics deployed in your plants. And similarly, there has to be a clear-cut business benefit that we need to come out with. Proper metrics for benchmark, because it can't be that, I have already found out, through the predictive analytics, well in advance that the gearbox will fail. So I can't say that, my value of predictive analytics is the cost of the gearbox. Ideally, that should not be the case. When people have found out early, which means that you've avoided the problem. So the cost that you've, saved is basically the problem in the end that you would be facing. So that is very important as far as predictive analytics is concerned. And there are also a requirement of data where you need the quality data. There are availability of key parameters. And sometimes there are inflated expectations. IPPs also say that, we have only 5 parameters. But you have to give us all the failure details. So this generally doesn't happen that way. So I would just like to ask a quick question from Varun. Varun, out of your experience, what are the success factors as far as AI project is concerned to deploy an AI project successfully?
I think in the wind farm context, there's few unique challenges facing the industry. One, your assets vary in geography, OEMs, environment factors, wear and tear, all things we've talked about right now. Second, we touched on this less, but it has implications. The nature of failure itself is very sporadic. It's not like you're falling down every day or anything like that. It occurs with less frequency. So you have less data. Your data sets for failure prediction are very sparse. And then thirdly, there is a greater need for change management, because you have what you're providing is to an operator who's ultimately in control of the switch, turn on, turn off. And so you need to be mindful of those 3 things that are challenges to you and build that into your success story. And therefore, we talk about AI, broadly speaking as well, it's a journey. You need to start small, think big and scale fast. And what I mean by that is get the data in one place for maybe 2 wind turbines. Don't go solving for your entire farm at one stretch. Start with a lean infrastructure. We talk a lot about bringing lean thinking to this. Use the metrics like Lakshman you were talking about to convince your senior executives and others that this is an investment worthy of more ammunition. And then also use that to convince the operator that you're bringing new value and you're kind of an ally to them, as opposed to taking their job away. The natural instinctive reaction is that you're going to replace me. And so those things, the hurdles are very key to break down, Lakshman, as you go through the process and go on that journey. I would conclude by saying, like, get the data, start in a small pilot, work on a lean infrastructure that you're trying to solve, convince the executives why, ultimately roll it out across a broader spectrum.
Thanks, Varun. That was very insightful, Varun. Thank you, Varun. Thank you so much. So, end of the day, we should also find the right digital partners. There are many BI organizations which say that we have a predictive analytics solution, but in reality they don't. It is not an AI ML based predictive analytics solution that they have. So it is very important that you need to choose the right partners. So with this, I would like to launch a poll again. So just to understand, what are your AI ML initiatives going forward in your organization? This is great. I think there are 67% of audience who are actually exploring opportunities to deploy predictive analytics in their organization. So that's a great result. So with this, I would just like to quickly go through one case study.
Interesting comment there. Lakshman is like, it's a 2/3, 1/3 split already in place.
Absolutely.
There's no one saying, no, I don't care for it. And
right.
the other pitfall there is if you're exploring, there is an urgency to act. If you wait too long, you might be behind the curve. And for those that are already in place and piloting it, it goes back to that pilot approach. And the partner comment that you made earlier, it's best to leverage playbooks from domain experts and be a force multiplier for what you're trying to do, so you avoid the pitfalls. But
absolutely
fascinated by that 2/3, 1/3.
That's great. Yeah. Even it interests me a lot, in fact. So with this, I would just like to go and talk about one of the success stories of RETINA360. RETINA360 is basically an AI/ML platform patented by Pawan Cybertech. And this platform has the ability to take data from your machines, do data analytics, and give you forewarning, and alerts well in advance. So in this aspect, for a 200 megawatt park, which is around 7-year-old park, we have found out problems in the gear sections, which we have forewarned well in advance, in generator sections, in main bearing section. So if you see, we have given a lot of value to our customer using the RETINA360 platform. So just to quickly give you a view what RETINA360 is, as I said, it is a AI/ML platform of Pawan Cybertech. It can pull in data from all the field equipment like SCADA, PLC, or you may be having an enterprise asset management system. It can pull the data, it can analyze the data, it can build models depending on the problem at hand. It can also then recommend, and it can give you some actionable insights further. There are, in terms of KPIs, charts, you can have any kind of customized dashboards that you would like to have. And end of the day, a clear-cut product that can give you a lot of benefit to your business. If you see, it's a technology agnostic platform. Today you may be having wind, tomorrow you want to have solar, it can seamlessly integrate. There are many customers who are using RETINA at this point of time, and some of them we have mentioned the top. If you see, RETINA has also been featured in the Kellogg case study, as we spoke some time back. Where the executive MBA students are learning about the importance of data. What can they do with the data? How are their business getting benefited because of this data? This was done by Mr. Mohan Birsani, was instrumental in doing this. He's the Associate Dean of Kellogg School of Management. And Varun has also been a co-faculty for this program and has had very good experience in in the AI/ML field. And Varun, why don't you just talk a couple of lines on this case study, Varun?
Yeah, absolutely. So as I said earlier, our course focuses on the applications of AI/ML, and we wanted to show some hard-hitting solutions where people can dive into the data, figure out details, and go from there. Mind you, this is a business school lens, so we weren't going at it from like, let's go build the next generation model. We wanted to highlight the application and the business impact. That said, what we loved about RETINA as we were building this was it gave students an end-to-end view from strategy and hypothesis, like which problem do I solve? How do I go at it? What do I need to tackle it? What sort of data do I get? How do I structure it? All the high level thinking down straight into the weeds of, okay, now I have this data. How do I instrument it and model it? And what insights do I draw from it? All that was very nicely packaged within the platform and allowed us to give students who have no knowledge of this industry the ability to craft a strategy for preventative maintenance. I emphasize no knowledge of the industry also, because we were scared. We did this case study and we thought people would complain all over the place. MBA students would not want to do that much work and say, what have you done to us in an 8-week course? And this exercise, this assignment has consistently exceeded our expectations. Students have come back and said they loved the detail, they loved the ability to take that concrete an insight and apply it to whatever industry they might come from. The energy ones were the most passionate, of course, but the others were equally energized by what they got to learn and apply. So that was one. The second was the importance of the practicality of it, that not all things can be predicted. And so we focused, you showed a chart of all the different parts. We focused on two things, the rotor and the generator, and we threw in a monkey wrench with a third one that couldn't be predicted because of the data and insights, and then students had to dig through that. And it was a good sort of lesson to hone in on. And the last piece, which again, from a business school perspective, was important to us, was the role of change management. I've highlighted that earlier. The operators are much like doctors. Unless you tell them why and explain it to them as to what the impact is, they aren't going to turn the switch on and off. And so building that trust, showing visually, intuitively why the AI/ML platform arrived at a particular decision was absolutely critical to us. And this platform, amongst others that we looked at, that was across other industries, was one that hit all those three needs. And so for us, it's been a very successful case study. Students have consistently come back and loved the lessons that we try to teach in it. So we've in fact had senior executives from BCT join us in live debrief sessions as well, which have gone equally well. So very happy with that.
That's great. That's great. Happy to hear that. So with this, I would like to end this session with the benefits of what Retina can bring to a business. So this is where we help. We help you to improve your yield, reduce your impact of downtimes, and improve your asset life by using data science. So what we have showed here as numbers with respect to increase in availability, yield, or revenue is something that our customers have vouched for it. So, definitely Retina, if you're looking for a predictive analytics solution for your wind parks, BCT's RETINA360 is something that you need to consider. So with this, I'm open for questions.
Hi, question from John here. Is the technology, if you've got assets in Europe, would it, with the data that's pulled off the system, is it comparable to, say, if you had technologies in other locations such as North America or Asia?
Ramesh, do you want to take that?
Yes, could you please repeat the question, Lakshman?
Can you please repeat the question?
Of course. So, I'm saying I have wind turbine assets in Europe, and I'm looking to acquire assets in a different geography. So the information that's pulled from the system, predictive analysis, would that be comparable to different geographies? So can one geography dictate what you would see in another geography, essentially?
If you're talking about predictive analytics, if you want a comparison, no. Generally, predictive analytics is built for that specific wind turbine. So when you're doing models, we will build models for that specific turbine, and we'll see the characteristics of how it works. Though few learnings we can apply if there's the same make or same model of the turbine, but ideally we can't generalize it from one part to another part.
Okay, thank you.
Thanks.
Thanks for the question, John. Would anyone else like to chime in with a question for the?
I got a question. I don't know how the contour where of the blade is assessed. See, because definitely you may not have a sense of a rotating component, which is a larger component, which is again a risky component if happens to fall from such an altitude. Is there a analytics for the blade wear, in terms of the contour?
Lakshman, I'll take that question.
Oh yeah, please.
Yes. Mr. Ganesh, thank you for asking that question. See, many of the data that we have from an operating turbine is not available in the SCADA. But then what is important in a blade? There are a few factors important in a blade. That is, one is the aerodynamic integrity of the blade. And the second is the amount of load, the load fluctuations, and the stress reversals that the blade root goes through. And that is what determines the life of the pitch bearings. Now there is a sensor, a load sensor or a strain gauge fitted to the root of the blade, but then this data is not available in the SCADA. But this data is definitely available to the OEMs who are monitoring this. And then this data is continuously fed to their servers where a lot of analysis happens. And that is how they come up with future models like the ones with longer blades or with a different power output. That's how it is done. The sensors do exist. There are strain gauges. There is data collection happening from the blades, but not available to IPPs. Does that answer your question?
Just to add that, if the data is made available to a predictive analytics company like us, we will definitely be able to do the models on that.
Correct.
Great, thanks very much for the questions so far. We'll just allow a couple of minutes more for any final questions, if anyone wants to jump in.
Yeah, this is Ravindran here. I do have one question. This is regarding when you talk about a model of a particular turbine, when you need to collect the data for a gearbox or a generator or anything, is there any time frame where you have the specific model of any particular gearbox model where you have a benchmark of data collected already, which is the benchmark to be compared with the new working one and older one, performing one, like that? Or is there any period of, if it is a turbine which is 15 years old, do you still have the data of that particular gearbox?
It is like this. For you to do a predictive analytics, for a specific turbine, minimum you need to have is a couple of years of data, which should give the accuracy to the highest extent. In case you say that you have only for 1 year, which is perfectly fine for us. We would still be able to do predictive analytics model, and as and when days go, the accuracy will be able to increase. Like say, if you have a 15-year-old turbine, you don't have to have exactly for the entire 15 years. For a year or two, the data is sufficient for us to do the predictive analytics model. Yeah.
Okay. Thank you.
Thank you.
Great, thanks very much, everyone. So one final question. How does Retina system deal with data from multiple OEMs?
Yeah, as I said, Retina is not only OEM agnostic, it is also technology agnostic. So Retina is basically a software. So the software generally doesn't, see it as a different set of models of turbine or anything. So it's a software which can collect data from any make or any models of the turbine, provided there is a data exchange protocol that is available. So, of course, it can go across models, it can go across technologies. In fact, we have also used Retina in the transportation industry. So, that actually tells about the software. So it can be used in any areas, any application, provided there is a data exchange protocol from a machine that is available.
Lakshman, we're currently using it on Enercon, Vestas, Goldwind. We're just about to roll it out on some solar and also using it on gas as well. So it's just an example of, multifaceted application.
Absolutely, that's great. In fact, we have worked on close to around 15 models of 15 makes of turbines because one of our customers is having almost around 21 wind parks of starting from 2 years to 21 years. So it's a diverse range of make and models of turbines that we work on.
Hey, this is Colton Massir. If I can ask one question really quick.
Yeah, sure.
Okay, so with our SCADA system, it only backlogs 3 years. Does your guys' system keep track of everything for more than that? Or could we even, in a sense, go back to, if we were to have you from COD, could we backlog and see that, say, 6-7 years down the road if we wanted to look back from COD to now?
Absolutely, absolutely, you can do that. We will. It's basically where Retina would be storing it in various formats. Maybe you may not be able to store a real-time data because the space constraint will be there. So it completely depends on how much of server space that you can provide to us. And Retina can store in data even for say 10-15 years per se. It's very easy.
Perfect. Thank you.
Great, thanks for the question, Colton. Any final comments or questions from the audience today?
Just one for me, actually, where you said you've got long-term service level agreements, and the discussion topic was, is it still worthwhile doing this when you have that in place? How do you find the engagement with the OEMs, considering they have budgetary constraints as well as all of us on this call, and they kind of have that final decision on whether proactive or a proactive change out is made? How do you find that engagement has gone?
Ramesh, you want to take that question?
Yes. Can you just shorten that question, Lakshman?
Yeah, so I can repeat.
Yes.
So
Yes, please.
where you have the long-term service level agreement, if when you go to the OEM and ask them and show them data that 360 have provided, have you find the OEM are engaging or not engaging? My assumption from my experience is they may not be engaging with that. They may not want to change out the part based on.
Yes, I'll answer that question, Lakshman. See, this is also regarding what you have experienced with, as a third-party service provider, has OEM been receptive to the data that you provide or the information that you provide? And then, see, I have been on both the OEM side and also as a service provider and also as a IPP. So I have faced issues where we did have the need to go in for a third-party service provider. And see, this happens because no matter what kind of an agreement we have with the OEM, they are only in failure management. They're not in performance management. And then since we need to go in for performance to ensure that we have a good LCOE number, we definitely need to go in for a predictive scenario where we are able to detect the root cause, formation of root causes in turbines much before they fail. And if we go with this kind of a data to OEM, they are not that they refuse it, but then they are reluctant to accept this. But then I would say data works. So I have been able to deal with OEMs where I have been discussing with them on several different makes of turbines. And this is with the operational data, the thermography, the ultrasound information, and also the vibration data. And then I present saying that here it is, and this machine is likely to fail in under 1 year or likely to fail in 2 years. So this kind of information, when it goes to the OEM, I've seen the responses. The response is encouraging. They don't accept it, but then I allow them to take it as their own. We say, okay, fine, you look good. Take this data, do it, and you look good doing it. So you may go and do it to other customers as well. But then this is how I have been tackling the OEMs.
Okay, thanks for that.
Welcome.
Yeah, we have been facing several such questions actually, and for them we also show examples of our customers. We take them to the site. We show them that this is how they did it, and it's also the power of negotiation that you have, how much you know about the turbine, what kind of analysis you do with the data. So it's a lot more onto that. I think convincing an OEM on your findings is going to be a great science that you need to master.
Yeah, I'll add to that, Lakshman. See here, since you mentioned data, the question comes as to who owns the data?
Absolutely.
Okay, sometimes the IPPs feel that, let us say, if you are coming in with your analytics, and then the owner wants to give you the data so that you can do a good job for them. But then the OEM could come in the way saying that, fine, the data is owned by me. But see, opinion is divided on this. I would say the data ownership lies with the owners, not the OEMs.
IPPs. Absolutely.
Okay. No, let us say, just imagine I am the OEM and I'll say, come to the owner and say, I got a new model 4 with all the bells and whistles. The bells and whistles are yours. The turbine is yours. You pay for it, but then I hear the sound. Okay, how silly it seems, correct? But this is what is happening today. That
Absolutely.
you pay for everything, but then you don't get the data. But that is not fair. And because of this reason, I see now in India, there are quite a few IPPs who are moving to third-party service providers. And then they are quite choosy about it. And then not only they have a different analytics team, they have somebody else for ultrasound, there is somebody else for vibration pickups, and they have a specialty laboratory for lubricating oil analysis. And then they have teams which combine all this together, and they're able to give them wonderful data on how to maintain these machines.
Excellent.
Thanks so much for the comments, Ramesh and Lashman there. I think we're just conscious of the time as we've reached and gone past the top of the hour, which is a great sign. Lots of engagement, so that's great. Thank you so much for everyone who contributed. We're going to wrap up today, as promised, with the raffle. So for everyone who's still on, we are going to announce who is the winner of the prize today, which is the Apple Watch. So I'm going to pass over to Reese now, who's going to do the honors.
Thanks, Liz. Sorry, I couldn't find the unmute button. So we used just a random number generator for all of the attendees throughout the session today. So it was drawn as 14. So I'll just drop over to the attendees spreadsheet so we can reveal who the winner is. I've not seen myself yet, so just bear with me 1 second. Great. Okay, so you should be able to see my screen. So 14, I'm just, for obviously data protection, I didn't want to share everyone's details, so just use the initials. But 14, it's WM from Energex, which I think, if I just look at the attendees quickly, that will be Walter McFarlane from Energex. So Walter, congratulations. You've won the Apple Watch. So we'll be in touch. I'll drop you an email after just to confirm all of the details and the delivery, etc. But yeah, great. I'll hand back to Liz. But thanks everybody for participating, and thanks to all of the speakers. So Liz, if you wanted to wrap up.
Yeah, thanks, Reese. Congratulations, Walter, for winning your Apple Watch prize there. Again, thank you so much to everyone who's joined the session today. So everyone who's spent the hour with us. And also thank you to our speakers today, Lashman, Ramesh, Mark, and Varun. Thank you for all of your comments and your insights. If anyone from the audience has any more questions for the Barwan or the rest of the team, please feel free to send them to Srini. I saw that Srini, his email was on the last slide. So if someone wants to flash up that slide with Srini's email, then attendees can send him an email. But otherwise, we will follow up with an email, just thanking everybody and sharing some additional contact details. So again, thank you very much, everyone, for joining the session today. Wishing you a good evening or a good rest of the day, depending on where you are. Thanks very much.
Thanks for the fellow speakers, Ramesh, Mark, and Varun. Thank you so much.
Thanks
everyone.
Thank you.
Thanks for joining.
Thanks, everyone. Thanks for joining. Yeah.
Thank you very much. Very interesting.
Thank you.
Thank you.